So over the past couple of lessons, we have been doing a lot of feedback gathering on our concept, and we have been changing our concept based on that feedback. So at this point, we should actually have a concept that people love, that you know would sell very well if you were able to manufacture it. So that is the point where it's time to start delving into DFM, Design for Manufacturing. And in this lesson, we will learn exactly how to do the design for manufacturing in collaboration with the engineers, and also learn what deliverables that you will need depending on which product type that you have. So with that, let's delve into it and start learning. The starting point of the design for manufacturing work that you will be doing now will be the renderings of your product concept. So these ones are the same ones that you use to validate your product concept with potential customers. Then the second thing that you need, it is a 3D model with accurate major dimensions of your product. And the good news are that if you have rendered images, that means that you also have a 3D model already that your designer used to create these images. So all you need to do is to ask your designer to send you this model in one of the accepted file formats. And if the model currently has the wrong scaling, so for example it might be too small or too large compared to what your actual product will look like, then ask your designer to scale the model so that the dimensions become what they should be, and then to save it, and then to send you the files. And then with these things in your hand, there are a couple of distinct paths which you can go down depending on which product type that you are making. And in this lesson, there are two major product types which we will cover, and those are number one, hard goods products. So as the name implies, things that are hard, things that are made out of plastic, out of metal, and so on. And then number two, soft goods product. So things that are made out of textiles and other soft materials. And let's kick it off by discussing what you will need to create a hard goods product. And the first thing that you will need, it is a manufacturing ready 3D model. And know that this 3D model, it's very, very different from the 3D model that your designer has used for creating renderings up until this point. This new 3D model, it will not only look good on the outside, but it will need to consider every single little manufacturing detail on the inside and look good as well. So it is much more complicated to create. And to get your mechanical engineer going with this 3D model, you will need to send them the 3D model that your designer did, the one that has the exterior major dimensions, which the mechanical engineer will be using as a reference. And then apart from that, you will hand the mechanical engineer the rendered images that you have been using for concept validation. And one final thing that you should let your engineer know before they get started with the design for manufacturing 3D model is how much you plan to produce of this product, and also what is the cost target of the product. So in other words, how much should it cost to bring this product out of the factory door? And knowing these things will help the mechanical engineer select manufacturing technologies with a reasonable tooling cost for the amount of products that you aim to produce. And once the engineer has started working, please don't be surprised if you quite quickly run into necessary changes that will affect the external look of the product. So maybe a part that was one part needs to become two parts, or maybe some shapes need to be adjusted for injection molding, or maybe some materials need to be changed for cost reasons. Either way, this is completely normal, and I personally have not been part of any project or even heard of any project where no changes happened during the design for manufacturing stage. With that said, if your designer has a good understanding of engineering, then you should not see too many fundamental changes to your product. So the core idea of your concept, it should still stay the same even after the DFM stage is completed. And if at some point the engineer requires a modification that would change the look or the function of the product too much, then it is quite possible that you will need to reach out to the designer again and explain the new information that the engineer has relayed. So it is very common and normal to work in this type of iteration loop with the designer and engineer at the same time. Now, before continuing, let's do some very rough cost estimations for how much a design for manufacturing stage could be for a hard goods product. And if we are talking about a freelance mechanical engineer who is able to work 25 billable hours per week, which is quite a standard amount of hours per week for a freelancer, Then for a product of low complexity, so a product like a phone holder or maybe Tupperware, then you should expect the DFM stage to take somewhere between 1 and 2 weeks. For products that are of medium complexity, so something that has more parts and a more complex assembly, then you should expect the DFM to take between 2 and 5 weeks. And some examples of medium complexity products could be a tripod, a pair of sunglasses, or maybe a wireless charging pad. And then if we go on to the highest complexity products like a coffee machine, for example, or a gaming controller, then I would expect to spend at least 2 months on the DFM stage. And obviously the sky is the limit in this case, so for some really complex products, you could even be looking at spending several years in design for manufacturing. But unless you have a huge budget and a lot of time to get a product to market, then of course I would not recommend to choosing a product of that complexity. And this cost estimation with these 3 categories of low complexity, medium complexity and high complexity, it's obviously quite rough, but I do hope that you have a hum now of where your product would fit into these. But to get the exact quote, you will need to speak with your mechanical engineer and ask them for an estimation. And by the way, when they give their estimation, unless it's a fixed price, then I would add at least 20 to 30% on top of that to get to the real estimate, because things go wrong and many freelancers, they don't account for things going wrong. But as somebody who has run a bunch of different projects, I know that you need to account for this in your budget. And then one final note on the cost estimations is that none of these estimates include the cost of electronics development. So if your product has some PCBs or electrical components in it, then you will need to include that as a separate cost. But for now, let us wrap up the files that you need for manufacturing hard goods with technical drawings. And the technical drawings, they are a complement to the 3D models that your mechanical engineer is now creating, and they show you things about your product such as surface coating, tolerances, and way of assembly. And you will need these because most manufacturers, they won't even quote you unless you can provide these technical drawings as a complement to your 3D models. So that was that for hard goods products, and now let's take a look at soft goods and the files that we need to manufacture those. And as before, to get started, we need the product renderings, we need the 3D model with the major exterior dimensions of the product, and also we need a cost target to get your engineer started. And unlike for hard goods, the end product here, it will not be a 3D model and technical drawings, but instead it will be something called a tech pack. And a tech pack, it's simply a PDF which details everything necessary for a factory to manufacture your product. And unlike 3D models and technical drawings, tech packs, they do leave some significant room for interpretation by the manufacturer. And this is because the standards around the tech packs, they are not as well defined as when it comes to standards for how to create technical drawings. There are, however, some common things which all tech packs must include, and those I will go through right now. And to display just how simple a tech pack could be, I will go through this tech pack for a t-shirt. And once we have gone through it, I think that you will see that the structure of a tech pack makes a lot of common sense, so you don't even need to be an engineer to see why it is the way that it is. So the very first thing that we need for our tech pack, it's a cover page which gives an overview over your product. And here we can see the example of the cover page for this t-shirt. And after that, we will need a page which shows how your product is constructed. And this construction can be communicated through so-called flats. In other words, drawings made in Illustrator usually, which show how your product is made. And depending on how complicated your product is, you will need a different amount of these flats to make the manufacturer understand how they will have to make your product. So for example, for this t-shirt, maybe 2 different drawings are enough, but if you are making a backpack, then you will need a lot more than that. And there are no fixed rules here really. Just make sure that the construction of your product, it's easily understood without a heavy reliance on text. Because remember that many of your manufacturers, they won't be speaking your language, or at least they won't be speaking your language sufficiently well to understand very nuanced points. And then moving on, the next thing that I suggest that you include in your tech pack is a page on stitching. So your designer, they should be able to recommend some different stitching types depending on what look you want and also how durable you need your product to be. Then next up, you will naturally need to include some dimensions for your product. And the way that this is usually done is by having a page that shows the points of measurement, like you can see on the screen right now. And then later on, you can include a table which defines these measurements for various sizes, if your product actually has different sizes. And then moving on, we have the colors of the product, and these should be defined using the Pantone range of colors. And Pantone, they have a great website where you can actually input hex codes, so this is something that you probably use if you're working with Photoshop or Illustrator. And the website, they will find the closest Pantone color available. And if you have different color combinations of your product, then you can show these on a page like they have done for these t-shirts right here. And then finally, once you have shown the structure of your product, the measurements and the colors, then you will need to define a bill of materials, a so-called BOM. And in our example for our t-shirts, this has actually been excluded because it's such a simple product with only two different parts, so the tag and the t-shirt itself. However, if you have anything just a little bit more complicated, like a jacket for example, then you will have many different parts and you will definitely need a separate BOM table. And to that BOM table, you should add exactly which materials the different parts have and also add the color codes. And as a bonus, to make things abundantly clear for the manufacturer, I would also add any renderings that you have done together with your designer. And this will really help the manufacturers understand exactly what you're striving for, and then if something in your tech pack looks different from the desired result, then they might even comment on it and suggest some other alternatives. And now with these renderings added and the BOM done, you should have a complete tech pack. And again, I just want to emphasize that a tech pack, it should be something that makes common sense. So even if you have no engineering knowledge and you look at a tech pack, you should be able to understand more or less how the product is made. You might not be able to understand exactly what the different stitching types mean, but you should be able to look at the construction pages and it should make sense to you. And then cost-wise, I'd say that you can expect to spend around $1,000 to $3,000 on the creation of your tech pack. And as before, the sky's the limit here, right? You can have an extremely complicated product, but in general, I think most products will fall into that range. And then finally, just to wrap everything up here with the hard goods and the soft goods as well, remember that even if your tech pack or your technical drawings or your 3D model is not perfect, then that's usually not a really big deal, because if the factory finds a flaw or if something is unclear, they will usually ask you about it, and then you can update the drawing and send them the updated version. And now let's wrap up this lesson with today's task. And the task, it will simply be to determine what files you need to manufacture your product, and then get your engineers going on creating those files.